Another aspect of your work is robustness. What does that mean?
Well, robustness can mean a lot of things. They were all managed from one place. Work did not work. You went to the one router that was where you managed the networks from, and you sent messages across the network to diagnose what was going on and to fix what was going on. Well, that doesn't work if the network is broken. So my first paper was sort of looking at the existing network, which was the ARPANET, and noticing that a few corrupted messages and the network would never recover. And that actually occurred after I published that paper, which was really cool. So my first paper was, hey, a network has to be much more robust than a single computer. So with your PC, it always does weird things or whatever. So you reboot it and everything's fixed. But with a network, it can have problems, and the ARPANET problem, rebooted one by one, all of the routers, did messages would come back and infect them. No way to fix it with their algorithms. So the paper basically said it has to be what I called self-stabilizing, meaning once you get rid of whichever computer is corrupting messages, once you disconnect it from the network, then the network should be able to return to normal operation by itself. And when I went back to grad school 10 years later, my manager at Digital Equipment Corporation, who was very smart, he said, gee, in your paper, you said that in order to make the network recover, you have to find and disconnect whichever computer is corrupting messages. That's the only way to do it, or figure out some other way. So my thesis was how to make a network resilient, even if some of the routers that are in there are misbehaving. So what behaving router do? It could give false information in the distributed routing algorithm, which is the algorithm is where everyone gossips based on what they know locally, compute based on that information. Or a sick guy, it doesn't have to be actively malicious, can give false information in that. Or it could flood the network with garbage so that the good traffic doesn't get through. There could be a router someplace that's doing everything perfectly, but it doesn't like a particular source way over there. And whenever it sees that source's packets, it throws those away. So I wanted to achieve in the thesis was assuming there's at least one honest path connecting this guy and that guy. They should be able to communicate with a fair share of bandwidth, even if every router other than the one honest path is arbitrarily malicious. And I've never done anything difficult. If you look at things from just the right angle, you can see how to solve it. And so I looked at it from just the right angle and I realized, oh my goodness, it's quite simple. So then I was afraid I wouldn't get a PhD for it. So I asked a professor, is there any minimum length to a thesis? And he said, well, it either has to be long or good. That's another example of resilience, which is even stronger than in my first paper. But yet another thing is making it work with people. So it's easy for engineers to say, well, that's bad users. They're configuring things incorrectly. Well, you should make your stuff not be so fragile that you should never blame people. You should realize that your system is not designed well if people can accidentally make things broken.
Well, that's really cool. So the string protocol solved a very practical but crucial problem in early networks. Do you think modern networking still prioritizes simplicity and correctness to the same extent?
Oh, absolutely. They do not encourage simplicity. These days, there's standards bodies, which is like a whole bunch of people. They also don't start out with the principle that I think is so important, which is know what problem you're solving before you try to solve it. So they start with all these buzzwords that nobody really understands, like zero trust, which doesn't actually mean anything, but it's a big buzzword today. They don't really know what they're doing, and they just want to be, oh, it'll be so exciting if we're one of the authors of some standard. And they just start doing something. And then it turns out they're not really doing a good problem. So they just sort of make it more and more complicated. And you get this mess afterwards that is sort of astonishing that anything works these days.